Okay, we looked at the composition of the beaches and the seasonality of it. You are seeing bright sunshine on my face. Why? Because the sun is shining on my balcony where I'm working with this nice lake view. Do you see this? Very nice. Okay. Coming back to the lesson, we talked about swash, the water coming in, and backwash, the water going back out with gravity, sand movement associated with it, and I said we'll have a pressure gradient created and longshore currents. So let's look at the seasonality first. So here is a summertime beach, as you saw in this cartoon before. Waves are light, they are long and nice, even swell like waves coming in, and low energy. So light wave activity creates wide sandy berms. The beach face tends to be nice and steep, and the swash dominates, which means the wave comes in nicely, deposits its water and everything, and the water soaks, and there is a slow backwash. So it's the swash that kind of dominates the process of deposition and building up the beach face. The longshore bar that we saw in the first schematic is not present because it's being washed up onto the beach, so it's used to build a nice smooth beach front and generally milder storms, right? Whereas in the winter, if you look at the exact same beach here in California, those cliffs you see are the California cliffs, and you can see that as we said before, the wintertime beach is going to be rockier because the wave activity is heavy, wave energy is heavy, and here the backwash dominates. So as the winter starts, let's say the waves begin to come in, break on the beach, and they soak in, and the wave activity is so strong that soon the entire beach face gets saturated with the water soaking in from wave after wave. So the next wave that comes in may not even have time to soak because it's so saturated, and the backwash is going to dominate. Okay, so it's essentially going to strip away all the nice sand face, high angle face that was built up, and a sediment is going to be moved away, and the longshore bar is going to be built in the water, okay, below the water. So the beach face is going to get flattened, and the weather is obviously stormier. So you can look at this impact in a table. So you can see that during the summer there is light wave activity. During the winter there are heavy wave activities. So the berms and longshore bars and wave energy time span over which these processes occur, and the characteristics of the beach faces that get created can be compared. So you have the berm being built in the summer with light wave activity, whereas the longshore bar is going to be built at the expense of the berm in the winter. Okay, the longshore bar is going to be moved up. All the sand is going to be moved up onto the beach during the summer. Wave energy is lower, and the time span is weeks and months. Light waves, long waves during the summer, and creates nice sandy beach, wide berm, steep beach face. Good thing, right? So summer is when we want to enjoy the beach, and that's when the nice beach gets built up, and the storm activity is weaker, waves are nicer, so everything works out. But during the winter, the exact opposite happens. Wave energy is high, there's short time span between the waves, backwash dominates, and the sand gets stripped off, and then longshore bar is built at the expense of the berm, and you end up with this kind of a rocky beach. Okay, we'll look at it some more, but just make sure you understood the seasonality and connect it to the previous concepts you already had about why winter storms and wave activity will be stronger than the summer. Has to do with energy transportation, equator to temperature gradient. Okay, again, if you want to relate that to global warming already, then you have to think, what happens with global warming? Will the equator to temperature gradient get stronger or weaker? And what will that mean for the winds, the storms, the rain, and the Hadley cell and the Walker cell and everything we had been talking about? So you can see that all the concepts begin to get combined, and you will have to synthesize all the pieces of information to produce understanding and new knowledge. That's the fun of learning.